will start now. Now, yesterday, I talked about mutually exclusive event, right? I say mutually exclusive event means what? They cannot happen at the same time. Okay? Now, I'm going to talk about independent or dependent event. Now, it's very easy about independent or dependent event. I want to tell you something here. Now, let's say I have a box. Okay? I have 2 red balls and 3 blue balls. Okay, all of you listen carefully. Wait that Jingyang up. If I draw a ball, right? I look at the color, I put it back. Then I draw again. Do you agree that the second draw is actually the same as the first draw? I don't have to depend on the first draw because I replaced it. Okay? Now this is called independent. That means my second draw is, the first draw has got no consequence on my second draw. It's independent of each other. Okay? Now, what do you mean by dependent? For example, I have the same scenario. Okay? This time round, right, I take a ball out. I'll put it aside. That means no replacement. That means the second draw will only have how many balls left? 4. That means my second draw is actually dependent on the first draw, right? That means got consequence, right? Okay, then we call this a dependent event. Everybody okay? If I replace it, it's no consequence. It's the same as before. So it's independent. Don't have influence on each other. But if I draw already, I don't replace, then there's a consequence. Everybody clear with what I'm saying here? Okay, now I'm going to show you with this example when I replace. I have 2 draws and I replace. That means they're independent, right? Okay, now first draw, red and blue. This will be a 2/5, right? This will be a what? 3/5. Now, when I replace, put back. That means to get a red is still 2/5, right? To get a black is still what? Sorry, a blue is still what? 2/5. So it's 2/5, 3/5, right? No change. Can you see? It's the same concept. Okay, now, what if I have no replacement? That means after I take out, I don't replace. You understand? Then got consequence. This branch will not be the same anymore. Okay, now I'm going to teach you this. Okay, all of you look here. Okay, it's the same thing. First draw, second draw. Okay, all of you look up. First draw is 2/5, 3/5. Confirm correct. Now, if the first ball is red, do you agree both left with 4 balls? If first ball is red, this one becomes just 1/4, right? Because only left with 1 ball. That's sweet. How about here? It's still 3, right? Correct. Now, how to check we are correct? When you add these 2, it must be 1. Understand? Now, how about if the first ball is blue? Then what do I have? How to get a red? First ball is blue. Left 4 balls. So it's 2/4, right? Then how about here? Also 2/4, right? Now, a lot of people will ask me, Cher, must I change this to half? Don't change to half. Leave it like that, I'll give you full marks. You know why? When you change, you forget you got deduct or not. You understand? I will tell all my teachers, no, they're not supposed to deduct. If they deduct, you can't find me, I'm going to scold them. You understand? I'm very particular. But when it comes to the answer, you have to reduce to lowest terms. But when it's at the branch, don't. Because it will confuse you whether you have deducted or not. Everybody clear? Okay, now repeat that. When it is independent, this side is the same as this side. But if it is dependent, that means I don't replace, then this one will have the denominator increased by 1. Okay, last year during prelims, we set one question like that, but we use it in terms of algebra. That means I have x balls, then 1 taken out, so it's x minus 1, that kind of thing. Then we form an equation, and in fact, they form a quadratic equation. Okay, and it came out in the tenure series before. Oh, talking about tenure series, actually I remember. Those under FAS no need to pay. Those not under FAS, right? Remember your E-Max is $6.50, your A-Max is $5. $4, sorry. $4. Because I remember $10.50. Now, I don't give change one. Can you bring exactly $10.50? Then I will walk around and put a plastic bag, you just dump it inside the plastic bag, and then I will take your name. Then when I go and collect from the auntie, right, from the bookshop auntie, I will collect 32 one whole shot. Then those with FAS, I think you got a book list, right, with a form or something to say that it's free, right? Then you go and show auntie. Is that clear to everyone? Yes or no? That is easier. Because last time some other classes, they go and buy one by one. Then after that, the teacher lost track of who took already. And that's very bad. Okay, each year you don't have to because I already written down, I only ordered 31. Everybody clear? Okay, so that's just something aside. Can you start bringing tomorrow so that I can start collecting tomorrow? Okay? Alright, so are you clear about the replacement and no replacement? Okay. This one is a very sad thing when students don't read carefully whether there's replacement or not. Okay, because it's a very easy question. There was one time, one whole class I took, only one person forgot to see whether got replacement or not, and actually she failed the test just because of this question now. Okay, because it leads to certain parts, correct? Okay, I can only award because it's a B1, that means it's only correct or wrong. I cannot give you any working. Understand what I'm saying? Okay? Alright, now next, let's move on to examples first. Okay, if you look at page 47 and 48, okay, you just read through them, okay. Now, for example 8, I'm not going to go through first. I'm going to go through example 9 and 10 first. Will that be okay? I go through 9 and 10 first, then I go through 8. Will that be okay? Then after that, I will give the homework. Alright? Okay, let's go through example 9 first. Okay. Let's look at example 9. This is an easy question. Okay? Example 9. There are 25 boys and 15 girls in a class. So I have 25 boys, 15 girls. Now, you must know this one total is 40 students. Understand? Don't calculate wrongly. Okay? Now, 12 of the boys and 5 of the girls wear specs. Understand? Understand the whole situation? Okay? Now, what did they ask for? A class monitor and a class monitress are selected at random from the 25 boys and 15 girls respectively. What is the probability that both the class monitor and monitress wear specs? That means it must be a boy and a girl. Correct? Agree? Okay, so the required probability. What's the probability of selecting a boy that wears specs? What's the probability of selecting a boy that wears specs? 12 out of 25. Now you must times this, both must happen together. Okay, what's the probability of selecting a girl that wears specs? 5 out of what? 15. You use your calculator. You just multiply these two, you will get the answer. What's your answer? Is it 4 over 25? Yes or no? Can you see this, what I'm talking about here? Can you see this is a very easy example? Example 9. Everybody okay? I'm moving on to example 10. Are you alright? Okay, let's go on to example 10. Okay, I will tell you how to get the answer for this type of questions. Out of 33 students in a class, 21 study geography and 12 study history. Clear? Okay, 21, 12. Okay, 2 students are picked at random from the class. Find the probability that the first student study history and the second student study geography. 1 student study history and 1 student study geography. Okay, I want to ask you a question. I go into class, there's 33. I pick one already. Can I still pick that one? That means there's no replacement. Pick one already, that means that's it. Pick already. Okay? So let's take a look here. All of you look up. This is geography, this is history. First pick. That's what I say, do maths 2 until 4 now. Textbook 4 now very funny. This one is what? Geography, 21 out of 33, right? How about history? 12 out of 33, right? Everybody clear about this one? This is the first student, First student. This is the second student. Now, let me ask you. After I pick one, the denominator becomes what? 32. Very good. This is what I always do first. I always write down 32 first. Then I won't make mistake. Okay, now, let me ask you a question now. If the first one is geography, how many geography students left? 20. Everybody clear? Okay, how many history? Is still 12, right? Can you see when you add, it must still be 32. Okay? Now, if the first one is history, this one is 31 still, right? How about here? 11, right? Everybody clear with what I'm talking about? This is when we have no replacement. Understand? Okay, so what happens now? Look at the question. The first student studies history and the second student studies geography. Now, you look at history. First student. 12 over 33, right? You're right. Second study geography. So, times 21 over 32. If it's along the same branch, you times. You get the answer straight. Everybody clear? If you want one from this branch and one from this branch, you must plus. Understand? If you go like that, you times. If you have 2 branches that give you the same condition, you must plus. I will show you later. Okay? So, are you okay with this one first? 12 over 33 times 21 over 32. Okay? Did I do it wrongly? History first. Alright, 12, 33, then geography, 21 over 32. Right? Okay, press your calculator. What's the answer? Press your calculator, what's the answer? Don't look at me, my friends got no calculator. Huh? What over? 40? 21. Okay, 21 over 88. Are you okay? Along the same branch with times. Okay, next one. Let's look at the next question. One student studies history while the other studies geography. Now, this one got 2 cases. I can have geography, history, then history, geography also can, right? So what's geography, history? 21 over 33 times 12 over 32, right? Now then I have history, geography also can, right? Can you see it's along the other branch? So it must plus. Understand? Then I have history, 12 over 33 times 21 over 32. Can you see history, geography? Okay, this one calculator can give you the answer. Just type what's the answer. What's the answer? 21 over? Yes. 21 over 44. Everybody okay now? Now what if I set another question? I want the 2 students to take the same subjects. So what do I do? GG plus HH. You understand what I'm talking about? GG plus HH. Understand? Along same branch 2 times, different branches in class. Everybody clear now? Yes or no? Yes, huh? Okay? Alright, so next thing. What if I choose the student already? I throw the student back to the class, then how? I throw the student back to the class, then how? This one will become what? 33. Right? It will remain the same because there is replacement. Everybody clear? Everybody clear? Can? Oh, so with replacement or no replacement is important. Okay, Okay, good. So 9 and 10 done. I'm going on to 8 because this one needs some explanation. All of you look at question example 8 first. Okay? Some people might be confused over this question. That's what I need to explain. Okay? Understand? And I hope I will explain it well. If not, then you have to read through it again yourself. Okay? All of you look at example 8. You see, when I ask you to wake up, that means you must wake up now. Then you make people walk fast. Let people come in and wake you up. You don't even know people came in. Oh my God. Never mind, it's okay. Don't know also good. Ignorance is a bliss, right? Hey, may I know why your Chromebook is on the table? Just like that, very confusing for me. I don't know whether you are looking at YouTube or what. Maybe I'm so boring. Okay, come. Example 8, page 49. There are 7 green marbles and 3 yellow marbles in the bag. The marbles are identical except for their color. Look carefully at the question. A marble is drawn at random from the bag and is replaced. That means you put it back. Clear? Okay? So, let's take a look. I have green and I have yellow. This is 7 upon 10. This is 3 upon 10, right? Correct? Okay? Then a marble is drawn at random from the bag and it is replaced. A second marble is then drawn at random from the bag. Now, do you agree that no difference? Because it's being replaced, the probability along the branches are still the same. I don't have to change it to 9. Do you agree? Okay, then comes the question that some people are confused with. Okay, I'm going to go through one by one. Okay, let's look at part 1 question. The first marble drawn is yellow. Straight away 310. First marble drawn is yellow. Correct? No need to know probability also no, right? Correct. But part 2. Let's take a look at part 2. What did they say? The second marble drawn is yellow, given that the first marble drawn is green. Now, they didn't say you want green and then what? The first one drawn is already green. You don't have to care about the first one. Do you understand the question? Okay, I read part 2 again. All of you look at part 2. Okay. The second marble drawn is yellow, given that the first marble drawn is green. Okay, let me teach you the scenario. You take out green, you put back. Correct or not? Do you agree this probability is still 310? Don't care about what, you just put back only, ma. Agree? Yes or no? So it's still 310. You don't need to go and look at so many things that they explain down there. It's just very logical one. Understand? Because I find the explanation makes you confused. Everybody okay? Now, then we look at part 3. This one got difference. Let's take a look. Find the probability that the first marble drawn is green and the second marble drawn is yellow. It's different from the second part. Second part already tell you it's green. They put back already. Understand? This one is what's the probability of getting a green yellow? Understand what I'm talking about? Okay, so how to get a green? First marble, 710, right? How to get a yellow? 310, right? Okay. So the answer is 2100, right? Everybody clear with the difference here? Yes or no? Because this one, it gives you the scenario that what's the probability of getting a green? There's still a probability. The second case is already green, finished, that's it. Everybody okay? Alright, now next, part 4. Let's look at part 4. The second marble drawn is yellow. The second marble drawn is yellow. Actually, it's just 310. Do you agree or not? Because regardless of the first marble, okay, the second marble is still 310. Correct? Okay, but if let's say you don't want, you want to say, oh, second marble is yellow. So first marble is 3 yellow. So it's what? 710 times 310, right? Second marble yellow, right? Plus yellow, agree? Okay, so it's 310 times 310. Now you will look up, this is 2100 plus 9 over 100. So can you see this is 30 over 100? It's still 310. No need even to think, it's still 310. Okay? That's why I find that this example 8 not very good because it confuses people. Can you see what I'm talking about? It confuses people. But don't worry, our question will be so clear that you will not be confused. Do you understand what I'm talking about here? Yes or no? Okay, so I repeat now. When there's replacement, this one remains the same. When there's no replacement, you must deduct. And no need to change to lowest term because it will confuse you. Only when you do out the answer, then you change to lowest term. Have I made myself very clear about dependent and independent event? Okay, that means it's actually with replacement or no replacement. Everybody okay? Okay, alright, good. What is the number on the content page now? Now 4 or 5? Now I write what? Now I write 5, yes. Because when I ask what is now I write what, okay? Now is 5. So today's date. Okay? Probability. Okay? Now, before I give you the homework, you can look through page 47 with example 8, independent events, example 9, dependent events, example 10, and so on. Okay? But, if you can understand what I say in class, it's okay with you. You understand what I'm talking about? Because reading that might make you confused. Okay? Alright, so let me just write down the questions that I want to do on full scan. I check whether I got leave out anything or not. Yes. That's good. Then can I add one more? Oh, this one will come out one more. Though it's at the advanced level, it's not really advanced. I want you to think, that's all. No, okay, this one, you think about it. I'll do for you tomorrow, can? Okay, ma? Can or not? Okay, question 17. Volcano one. The volcano will erupt or not? Okay. I don't care about geography, I don't understand a single thing about geography. Okay, really, I can't stand it. The most hated subject of mine is chemistry. I can't stand chemistry. No matter how hard my teacher tried to explain to me, I just don't understand. And the teacher just came in with like, what is a precipitate? So the whole life in my secondary school is precipitate. Okay, precipitate, what grey color lah, yellow color lah, don't know what color. Then I was thinking like, what the shit, right? You just tell me precipitate, then how am I supposed to know? Then I cannot imagine how come got electrons flying here and there. You know what I'm talking about? You say there's a nucleus, whatever lah, I don't know what is it called in the center. Then after that got electrons fly here, fly there. Then I walk, I don't see ma. How you know the atom looks like that? I don't understand no. You understand what I'm talking about? But you walk, you say there's molecule, how I know? I cannot see. But physics, at least there's friction, I know that I walk, I can walk now. Then I see the spaceman go to moon and float, that kind of thing. So at least I know gravity not there lah. But chemistry I cannot understand all of it, sorry. Okay, I can't stand it, okay? Don't tell me about chemistry, I'll just freak out and die. Okay, so I will start for you and then you continue, okay? Okay, let's start with question 1. Take down already or not? Take down already or not? Okay, number 1. Ethan has 2 bags containing 5 black marbles and 4 red marbles. That means that the 2 bags contain the same thing, don't understand? Hey, talking to you okay? Ethan has 2 bags each containing 5 black marbles and 4 red marbles. He takes 1 marble at random from each bag. Okay, can you draw that probability tree diagram first? Black, red, okay, now this is the first bag. This is the second bag. Can you see they contain exactly the same thing? Okay, so that means they are independent, right? That means you don't have to care about the first bag or second bag. Okay, so 5 black and 4 red. So 5 over 9, 4 over 9. 5 over 9, 4 over 9. Am I right to say that? I can just fill it up like that, correct? Because they are different bags, so they are independent of each other, right? Okay, now let's take a look at part 1. I just want to know, have you taken this down already? Have you taken this down already? Yes, okay. Then we can start with part 1. The question says, find the probability that Ethan draws a black marble from the first bag. So very easy, what is that? 5 over 9, right? Am I right? Okay, part 2. A red marble from the second bag, given that he draws a black marble from the first bag. Now, does it even have consequence what he draws from the first bag? So how to draw a red marble from the second bag? It's just what? 4 over 9. Is that clear? Is that clear? Okay, now next one. Part 3. A black marble from the first bag and a red marble from the second bag. Forgot already. What did you want? Black from first, red from second. So it will be 5 over 9 times what? 4 over 9, right? Answer? 20 over 81. Is that understood? Okay, good. Last part. A red marble from the second bag. Do you agree just 4 over 9? Yeah? Yes, wait. Let me check first. Yeah, why? Black marble from first bag, red marble from second bag. So it's clear. It's times on it. Part 2. Okay, wait You look at part 2 Part 2 says okay, that's a question, okay? Part 2 says a red marble from the second bag, given that he draws a black marble from the first bag. Now, They already tell you first marble is black already. So there's no need to care about the first marble. You get what I mean? So you just have to care about this side. That's why it's just 4 over 9. You understand? But whereas part 3 is different. They want a black and a red. There's a probability for both. Okay, now actually this one is not just called a tree diagram. It's called a probability tree diagram. Okay, now what's the difference? Can you see that there's more chance of getting a black than a red? Because it's 5, you know. You understand what I'm talking about here? Can or cannot? Okay, Now I'm going on to the next one, which is question number 4. Can all of you look at question number 4? I don't know why they like Eton so much. They always like Eton. Number 4. Eton takes either bus A or bus B to school every day. Bus A and bus B either arrive punctually or late lah. Of course, this is they may never come earlier lah. Punctually or late lah. The probabilities of bus A and B arriving punctually are these. Okay. I want to write down. Bus A. Punctual is how much? 2 over 3. Bus B, punctual is 7 over 8. Okay. Now then I want to ask a question now. What's the probability of bus A being late? One over 3. Because they say it's either punctual or late. Only 2, don't have come before time. Okay, now what is bus B being late? 1 over 8. Am I right to say that? So I have to establish this first. If not, later we are run into trouble. Understand? Okay, let's look at part 1. Both buses are punctual. What is the probability that both buses are punctual? It will be 2/3 times what? For both, you want both to be punctual, both must happen at the same time, right? So you must times, right? It's not plus. Plus means either this or that. I want both to be together. Okay? So I will get what? What will this be? What's the final answer? 7 over 12. Alright. Next. What is the probability that bus A is late while bus B is punctual? Bus A late is how much? 1/3. Bus B punctual is what? 7 over 8. So 7 out of 24. Everybody okay? Yes or no class? Yes, Okay, next one, last one. Exactly 1 bus is late. Exactly 1 bus is late. Now, if this is late, this got to be punctual, right? So I will have 1/3 times 7, 8. First scenario, right? Okay. Now I tell you why is it plus. This is times, right? Both must happen. Plus. If this is late, this must be punctual, right? So it will be 1/8 times 2/3. Correct? Okay. So what is this answer? Out of calculator, this calculator. Don't do mental sum of this. 3 out of 8. 3 out of 8. Everybody clear? Everybody clear? Okay. Now, class, what if you say, oh, sure, I die already, right? I don't know how to see this kind of thing, right? So what you actually can do is this. This is bus A. This is punctual, this is late. Punctual is what? 2/3, 1/3, right? Then you have bus B. Punctual late, punctual late. 2/3. Okay, no. Bus B is how much? 7/8 and 1/8. Correct? I will show you that it's the same. Okay, I want to show you that it's the same. Okay, now, first question was, both bus are punctual. So, this and this. Now, can you see? Can you see? Oh? Next one is what? Bus A is late and bus B is punctual. Late and then punctual. 1/3, 7/8. Can you see? Yes or no? Okay, last one. I'm going to use another color. Last one, they say exactly one of the buses is late. All of you look here. So I will have late, punctual, right? Then I will have what? Punctual late, right? So 2/3, 1/8. 2/3, 1/8, and then 1/3, 7/8. 1/3, 7/8. Everybody clear? Everybody clear? But I just think that for this type, right, there's no need to go and draw a true diagram. I just can see from here. Okay? Can? Okay, Alright, that's good. That is question 4. Now, I will leave you to do the rest yourself. You continue now. Okay? You continue now. Can we stop the video?